Today we talked about dot plots. So I'm going to show you how to make one and how to analyze one. So Mike is practicing for a swim meet. His practice times in seconds are 62.5, 63.0, etc. So these are all his times. We're going to make a dot plot of this data. The first thing I'm going to do is put these in order. So let me look at what the smallest one is. 62.0 looks like it's the smallest. So I'm going to write that down, 62. Are there any others that are 62? Nope. So what's next? 62.5 looks like. So there's 1, 2, 3, 4, 5. So 62.5. I'm just going to say 62.5 5 times. And then next would be 62.75. So there's 1, 2, 3, 6. There's 62.75 3 times. And there's 63 shows up 1, 2, 3, 4, 5 times. So 63 shows up 5 times. It might be, you could just write 63 5 times, 62.75 3 times. You can write 62.5 5 times, but I'm too lazy to write all that stuff. So I'm just going to do this. So now I need to fill in this, this dot plot, the labels on the dot plot. So now I have, it goes from 62 to 63, and halfway between there's 62.5. Now, I know that I have between 62.5 and 63 is 62.75. I see that right there. 62.75. Now, what goes here? Well, I don't have anything here in my data, but I still need to fill this in. So what's halfway between 62.0 and 62.5? Well, if I write down 62.0 and 62.5, I know the number that's in between is going to be 62 point something. Well, you know we can add zeros after a decimal number and it doesn't change anything, right? Well, I'm going to do that to make it easier to see what's in between these two. Now this is 0.00, 62.00, and this is 62.50 now. Now what's halfway between 0 and 50? 25. So 62.25 goes here. So now what I'm going to do is I'm going to put dots above all of these numbers to show how frequently they show up. So let's take a look at this. 62 shows up 1 time. So I'm going to put 1 dot. Let's see if I can make that a little bit bigger. There we go. And 62.25 shows up 0 times. So I don't put any dots. 62.5 shows up 5 times. So I'm going to put 5 dots. 1, 2, 3, 4, 5. 62.75 shows up 3 times, so I'm going to put this one 3 times. And I'm going to line these up. So this one lines up with this one, this one lines up with this one, this one lines up with this one. This is so that I can compare the two evenly. If I made these really spaced out, it might look like they're the same number of times, but that wouldn't be accurate, it wouldn't be useful. So I want to make sure these line up more or less evenly. So 63 shows up 5 times, so I put 5 dots above 63. And I line them up with this one because they're the same. So that's my dot plot. Now this is a graphical representation of all of his times, and I can see this is much easier to read than all this list of numbers randomly sorted. I can see that most of the time he gets 63 or 62.5. One time his time was really good, it was 62, but that's unusual. Okay, now we're going to analyze some dot plot that exists. A breakfast chef uses 3 different amounts of milk when making pancakes depending on the number of pancakes ordered. The dot plot shows a customer's orders for pancakes one morning. How much milk does he need to make all the pancakes? Well, so let's see. How many people have orders that require 1/4 of a cup? 2. Let me make that thinner, easier to read. 2. And 2 people have orders that require 1/4 of a cup. So I'm going to multiply 2 times 1/4. How many people require orders that have orders that require half a cup? 1, 2, 3, 4, because there's 4 dots above half a cup. So I multiply 1/2 a cup times 4. Remember, we're trying to find the total amount of milk that's going to be used for all these people. And then 2 people have orders that are bigger. They require 3/4 of a cup. Okay, so now if we remember how to add or to multiply fractions, first thing we got to do is change this whole number to a fraction. So I'm going to change this to 2 over 1. That's the same thing as 2. I multiply that by 1/4. And I get 2 times 1 is 2. 1 times 4 is 4. And I simplify that. I divide top and bottom by 2, and I get 1/2. So let's do the same with this one. 4 becomes 4 over 1. I multiply that by 1/2. And 4 times 1 is 4. 1 times 2 is 2. Now I'm going to leave this, even though I could simplify this, I'm going to leave it in this format because I'm going to add these later, and I want them all to have the same denominator. I notice this is something over 2. This is also something over 2. That might be convenient to leave it that way, so I'm gonna leave it that way for now. So 2 times 3/4 would be 2 over 1 times 3 over 4. 2 times 3 is 6. 4 times 1 is 4. Now I want this to, I'm going to simplify this one because I want it to have a denominator of 2 if possible. So I'm going to divide the top and bottom by 2 and I get 3 over 2. So this is the total amount of milk that's needed for those people that are on a diet. They're not ordering very many pancakes. This is the amount of milk needed for all the people ordering lots of pancakes. And this is the amount of milk for everybody else in the middle. So we got to add up all this milk now. So they all have the same denominator, so that makes it very easy. 1/2 plus 4 over 2 plus 3 over 2. Denominator stays the same because I'm adding. They all have the same denominator. If they had different denominators, I would not be able to add them. I'd have to change that. But they do, so that makes it easy. 1 plus 4 plus 3 is 8. Now I can simplify the answer. I can divide the top and bottom by 2. I get 4 over 1, and that equals 4 cups. So the chef needs 4 cups to make pancakes for all these people. So we're going to just analyze one more dot plot. So this is the ages of students in science club. So this many people are 8 years old. There's no 9-year-olds. This many people are 10 years old. This many people are 11 years old. This many people are 12 years old. So how many more students are 10 years old than 12 years old? So let me count the number of 10-year-olds, first of all, by counting the dots above the number 10. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 10-year-olds. How many 12-year-olds are there? 1, 2, 3, 4, 5. There are 5. There are 5 12-year-olds. And so now I'm going to subtract them to figure out how many more 10-year-olds are there. This looks like there's more 5th graders involved in science club than 7th graders because 5th graders are awesome. 8 minus 5 is 3. So there's 3 more 10-year-olds than 12-year-olds. So, how many, this one asks the same number of students are what 2 ages. So we're basically looking for 2 ages that have the same number of students enrolled in science club. So this one has one, I know this is 8, this has 8 kids. So there are 8 10-year-olds, there are 5 12-year-olds, and there are 1, 2, 3, 4, 5, 6. There's 6 8-year-olds and 6 11-year-olds. So it looks like the number of 8-year-olds and the number of 11-year-olds is the same. So 8 and, that's an ampersand, 11. 8 and 11. So those 2 age groups have the same number of kids. What is the range of ages of students in the science club? Now, the range is going to be the biggest age minus the smallest age. If you forget what range is, look at the context of this question. It's asking for the range of ages. So that means that I'm somehow doing something with the ages, not the number of people in each age. So to find the range in a dot plot, I find the biggest number that has dots above it. In this case is 12. So if I had 13 here, there's no 13-year-olds in the club. If I had 13 here and I didn't have any dots above it, I would not pick 13 as my biggest number because there's no dots above it. And then I subtract the smallest age that has dots above it, which is 8. Remember, if I had 7 on this dot plot, I would not have any dots above it because I don't have any 7-year-olds in this club. And I would not pick 7 as my lowest number because there's no 7-year-olds. But there are a bunch of 8-year-olds. So I subtract the biggest and the smallest age where there are students enrolled. And I subtract these and I get 4. The range of ages is 4 years.